We are live, sir.
Okay. So, guys, good evening, everyone. So, I hope you are all set and ready for this session. In the last session, we had just an introduction about this linked list. I mentioned this self-referential structure and what is basically a node, and I had discussed about this create function, right? So, through which we will create a particular node. Like every time I would need to create a node, I'll just call that create function. So that would create a node, right? So in this session, it would be more of this linked list thing. Yeah, good evening, everyone. Yeah, good evening. Uh, yeah, this should be more of this linked list. We'll do some operation. We'll see how to basically create a linked list. We'll link this node together and I'll see some operation. So yeah, fine then. So we can carry on with our discussion. Sorry. Yeah, good evening, Ravi, Susan, Lavish, and yes, lighting stars. Yeah, Kashyap, good evening. So yeah, I'll just share a screen with you quickly. Just a moment, give me a moment. You remember this thing we discussed in the last class? This thing, this create thing, and I remember some one or two guys were asking to repeat this thing, but I was running short of time. We are actually at the end of the session, so I could not repeat this thing. So for those people, for them, I'm repeating this thing in a quick way. So I have this function, excuse me, whose return type is node star because I'll be returning an address of a node. Okay. So this create function, which is taking an argument, basically data of the new node. Okay. So every time I want to create a new node, I'll be going into this way. Node star new. This is basically a pointer new. And yeah, typecasting, we already have discussed about this. So malloc and size of one node. So I want a memory. I want to allocate a memory for one node, right? So that would be stored in this new thing, new pointer. Then in data part of new, I would store this x, and then new of next would be null because we have just created a new node. We don't know about the what would be after it. So we are just storing null, and finally we have to return address of this new node, and address of this new node is stored in this pointer new, right? So I'm returning this new. So whenever you want to create a new node, let's say in main function, I want to create a new node. So I will be writing this node star, or take any pointer name. I've taken nptr equal to, and we'll call this create function, and we would send a value, like whatever value we want to assign in the data part of the node. I'll be doing this create 20, and 20 will be stored there. Okay. So this is how we are doing. So this create function will create this node, store 20 in the data part, null in the next part. Let's say address is 401, so it would return 401, which would be stored in this nptr pointer. So we say nptr is pointing to this node, right? So this is how we create a node. Okay. Okay, then. So let me clear this thing, and we'll move forward with our discussion. Okay, so now it's about like how to create linked list. We haven't created a linked list till now. We have just seen like how we can create a single node. We are yet to create the linked list. Okay, so let's carry on. Let's go on with this. So for that, I would be using this insert at end operation. Insert at end operation. Like insert would insert a new node, right? And we'll go on inserting new nodes, and after short while we'll say there would be some nodes in the linked list, right? Okay, so let's see how this insert thing is being done. Okay, so here I'll talk about various contexts, various scenarios. So first, let's say I'm talking about if there is no node, like linked list has not been created, and you are now trying to insert a new node at the end of the linked list. So when linked list is not created, then head at that time would be null, right? Head would be null in that case. no linked list at all, no node at all. So head value would be null, right? So if head would be null, then what we have to do, we are now trying to insert a new node at the end of the linked list. And linked list is empty. So basically we are trying to insert the very first node, right? So what we would do, here we will check. How to check whether the linked list is empty? We'll check if head is equal to null. Okay, you can write this thing, or you can write not of head. Instead of writing head equal to null, you can also write not of head. See, whenever head would become null, or when head is null, not of null would be true. Okay, if head is not null, if it is holding any address, then not of that address would be false. Okay, so we can either write head equal to null, or you can write not of head. Got it? So insert addend head equal to null. Fine. If head is equal to null, that means our linked list has not been created. We are now trying to insert the very first node. Yeah. So we are trying to insert a node. So obviously we have to create that node first of all, right? So let's create that node. I'll just say node star new equal to, we call the create function, and let's say data is 10. Data of the new node is 10. Just this simple instruction, this statement would give me a node with data 10 and next part null, and new would be pointing to this. Let's say 101 is the address, so this new pointer would be holding 101. So if head is equal to null, that means this is the very first node we're trying to add at the end. So in that case, what we can do, we will just make head as this new. Basically, we are assigning the value of new to head. So this head value, which was null, now it would contain 101, and head would be we say head is pointing to this node. Basically, we have added this node to the linked list. So we have our first node. So how is our linked list? How it is there? The linked list is basically this, right? All these nodes would be linked together, and the first node would be pointed by head. Let's say it is 101, so head should be storing 101, right? This is how linked list looks like, right? So we are doing, Satyam, we are first of all going with linked list. I'm explaining this insert at end operation. Okay, so yeah, so this is how we didn't have any node at all, so we created the node, right? We created the node, and then we checked if the linked list is empty, then add, like this should be the first node, so head should be pointing to this node now. So I just made head equal to new. I don't have to like do anything, so from here I can return head. Okay, so now you may ask me why we are returning head. Okay, why we are returning head, that may be your question, right? Let me also erase this part because I want to explain something here. See this. Okay, so see guys, in main function we create this node star head equal to null, right? And there we call this insert function. We call this insert function. Okay, just a moment. We call this insert function by passing this new data, for example. Okay, insert, I need this head thing and also the new data. So why I'm sending this two argument head and 10. See, head is where you would start accessing the linked list, because see, how can you access the linked list? Through head, because head is the starting, you can say, node, or head is pointing to the first node of the linked list. Through head we can access the entire linked list. So I need to pass the address of first node, that is nothing but head, and the data of the new node which I want to insert. So insert head comma 10. Okay, so this function, you can say, it would accept two argument. One is this head address, first address of first node, and an integer, basically the data part. So if it is accepting this data, then we can actually directly pass this data here. Are you following me, guys? So I'm see what I'm sending to insert function. One is address of first node and the data of the node which I want to insert. So when I'm creating new node inside this insert at end, okay. So while we call this create function, so I need to pass this data. I need to pass this data. Data is maybe 10. Yeah, data here is 10. So it would create a node with data 10. Whatever data it would be, it would just create with that. Yeah. Yes, Brij Kishore, start, we also take start. You can take head or you can take start. No issue on that. Okay. So yeah, so insert head comma 10. So guys, can you tell me? So this head, this head, node star head, whatever we have mentioned here as argument in this insert function, and the head which we have created or declared or defined in main function, are these both things same? Are these both the things same? This head and that head is the head which we have in this insert at end, and the head which we have in this main function. Are the same thing? I'm changing here this head, right? Okay. I'm changing here this head. Okay. Yeah. Tell me. They're not same, guys. This head actually is local in this function insert at end, and this head is local in this main function. Okay. So we have actually two head. One of this function, this insert at end, and one of this main function. So when we have changed here, when we change the value of head here, we have assigned new to head. So that means we actually changed this head, the head which is there in insert at end, the local head we change, but the original head, the main or the head inside the main, that has not been changed. So that is why I'm returning this head, like value of the local head that can be stored in the head of the main function, so that original head would get changed. So earlier it would be null, now it would be 101, because your head value in this insert at end function would be 101, and that is what we are returning from here. Is this clear, guys? This point clear? Why I'm returning this thing? I'm changing here, I'm writing here head equal to news. Basically I've assigned this new to head, but the thing is the local head got changed. Original head that is there in main function has not been changed. So I would return this new value of head that would be assigned to the original head of main. Clear, right? So that's what we are doing here. Okay, so if we are seeing that okay, head is null, that means head yeah, there is no node in the linked list, then we would assign, we'll store the address of the new node in head and we'll return this address. Basically the value of head will return. So we are done with that. So we are done with only one condition, guys. When the linked list is empty, then again linked list may not be empty. There might be some like many nodes, there might be some nodes there, so maybe this one. So yeah, these are the, let's say, nodes in the linked list. So this is head, maybe 101, and this is, let's say, yeah, value is 101. Let's put some values here, 10, 20, 30, kind of this. So if I want to like go to this what is there, I want to insert a new node at the end, right? So I need to add a new node, so this would be new, already we have created. So maybe data is 35 and it is null. So we need to add this node at the end of the linked list. That means this thing, it would be null here. Now this null should be replaced with address of this node. let's say address is maybe 401, so the value here should be 401, so it should be pointing here. So how to do this? In order to change this next part of this node, I need to access this node, right? How to come to this node? We can access the linked list through the first node actually. Okay, so from there we have to come to the last node, and the moment when we reach the last node, let's say a pointer temp is pointing to the last node now, then we can easily write, right? We can easily write temp of next equal to new. So address of this new node will be stored in next of temp. So that way we can link. But how to get this temp to this last node? That's what we have to find out. So we know that we would be starting with head, obviously first node. With first node we'll be starting. So it would be, we will take a pointer, let's say temp start temp equal to head. We may also write this step like here or something. That's depend on you. Fine, I'll just go on this. So nodes, I'll just go on with this. So node start temp equal to head. So here it is. Then I would be moving this temp. I'll shift this temp one by one till we reach the last node. Are you getting my point? Okay, so till we reach this last node, we would be shifting this temp. So how to shift the temp? So basically we have to continuously shift it towards right. So I'll be using a while loop. Okay, I'll be using a while loop. So while temp equal to temp of next. So temp, I'm storing temp of next in temp. What is temp? Let's say temp is pointing to a node. Let's say temp is pointing here. What is temp of next? Temp of next would be address of this node, and that I am storing it now temp. Right. So temp will not point to here anymore. Now temp would point to here. So temp equal temp of next. So I'm basically shifting this temp one by one. So till what point this loop should run? Loop should run till the moment I reach the last node. How can I reach the last node? Like what would be condition? Where should I stop the loop? What should be stopping condition? Stopping condition should be, guys, we have to write while temp of next. You can write here temp of next not equal to null, or you can just write temp of next. When temp of next would be null, the loop condition would be false and it would stop. See what do I mean by this temp of next? What do I mean by this temp of next? So temp of next means the condition here till temp of next is not null, the loop will run. Okay, see here. See here. So here I am now, temp. Temp is here. So temp of next is not null now. So temp would be shifted. So now temp would be here. Now temp of next is not null. So temp would be shifted. Now temp is here. What is now temp of next? As there is no more node, temp of next now would be null. So this is where your loop would stop. So after completion of this loop, if you are coming here, after this loop, we say that temp is actually pointing to the last node. Now our task becomes very easy. We can just write temp of next equal to this new. Okay, right? So this is what we are doing, guys. Did you follow this, guys? And yes, finally, as this insert at end function will have a return type of node star as we are returning here. So we would also return here this, my bad, we'll not write node head. We will write return what this head, same thing. We'll return head, address of the first node. So here in this case, head is not getting changed. You are just returning the same value. That's fine. So the same value will be assigned again to the head of main. But in this case, obviously the head is getting changed. It was null. Now it would be storing some value. It would be holding now a new value. Is this clear, guys? This thing. Okay. So so first of all, what I'm checking if the linked list is empty if there is no node. If there is no node, then this head, I'm making this head as new. Basically, I'm storing the address of the new node in head, and then I'm returning the new value of head by writing return head. Otherwise, if there are some nodes in the linked list, I'm taking a temp pointer starting from this first node, and then I'm shifting it till I reach the last node. And this thing would do that up to this one would do that. Okay, right? And then what happens? So when I reach the last node, so this loop condition will be false. I'll come out of the loop. Then I'm storing the address of the new node in temp of next. Temp is pointing to last node, right? And in next of the last node, I'm storing the address of this new node by writing this temp of next equal to new. Then finally, I'm returning head. Same value would be returned basically. Okay. New of next equal to null, we don't have to write. Already it is null. Okay, while you are creating the function, while you are creating the node, already null has been like put there, right? Null has been assigned there in the next part of temp. Sorry, next part of new. So you don't have to do it again. Okay. So yeah, so just a quick brief. Let me tell you. So first of all, we want to insert a new node at the end of the linked list. So obviously we need to create a node. So basically that's why we are calling this create function, which would create a node for us, and we will have address of that node. Then we are checking, are there any node in the linked list? Is the linked list empty or it has any node? So if the linked list is empty, that's why I have mentioned here the condition. If head is equal to null, then I should be storing, basically I'm trying to add the very first node of the linked list. So I'll be storing the address of this new node in this head. So that's why I've written head equal to new, and I'm returning this new value of head because I need to assign that in the original head that is there in the main function, right? If head is not null, that means if there are certain nodes already, then I need to take a temp variable which would start from head pointer, which would start from the head node, and it would shift until I reach the last node. When I reach the last node, this loop would break, I'll come out, and then I will store address of this new node in the next of this last node. And finally, again, I'll be returning head. Okay, basically this time in this return head statement, the same value of head would be returned and would be stored in the head of main. I hope it's clear. Okay, it's clear. Is it clear, guys? Yeah, I'm waiting for a response. Is it clear? Yes. Okay. Fine then. So I'm erasing this thing stuff. I'll just be I was explaining, so it was a kind of I was scribbling, so I'll just write in a proper manner here. So you see this. So the function looks like this: node star insert maybe end. So it would receive this two thing. One is the address of the head node and the data of the node, right? Then what we have this new. We have to create the new node. So create data x, right? Then we would check if head is equal to null, or you can just write if not of head. Then we would assign the address of new node in this head, and we can just return this head. Okay, if head is not null, then we'll be taking one temp. Basically you should be doing this in the like first step. At least you should declare the temp in the first step. Anyway, this is fine. I'll start from the head node, then I will loop inside the loop while I reach temp of next. Basically, until temp of next is null, this kind of loop will continue. And what I'm doing, I'm basically shifting the temp to the next. I'm storing the address of next node in current temp. So temp is getting shifted. And after this loop, if I'm reaching, or you can say after finishing of this loop, temp would be pointing to the last node. So in next of last node, if I store new, then the linking would be done. Okay, and then finally I can just return this head again. Got it? So this is how your insert at end looks like, guys. So this is insert at end. Similarly, if you talk about insert at beginning, there is a certain point. Let me quickly finish that thing. So if you talk about insert at the beginning, so I have certain nodes here. Okay, so this is my head node, and I want to insert a new node at the beginning. So this is my new node, let's say, and this is new. I'll put some data 5, 2, 3, and let's say this is my guys will check in the same way whether there is this whether there is any whether there is empty. Okay, maybe I'm saying, okay, we'll go in this way. Mm, Two scenarios we'll take. One is if the linked list is empty, if there are no nodes at all. Okay. Second is if there are certain number of nodes. Two scenarios let's take. So let us go with this case where we have certain number of node in the linked list and I want to add a new node at the beginning. In that case, what we would do, it's very simple. You will write new of next equal to head, because head would be pointing to the very first node. Then we would be changing the head to new node, because new node should be the new head, right? Head should point to the new node now. So we have linked this new node, like we have we have added this new node at the beginning of the linked list. Then one more scenario is if there is no node at all. If there is no node at all, then what would be the head value? We have what the value would be null. Will this piece of code work like new of next equal to head? What is new of next? New is the new node. Fine. Or new in new of next we are storing head. Head is null, so null would be stored. Okay, because there is no node in the linked list, so null would be stored here. Then what we are doing, we are making head equal to new. So we are storing this value of new in head. So this would become the new head. Yes, that's what we wanted. Head is now this new node, right? Okay, so this is what we are doing, guys. This is how we go for insert at beginning. Like this piece of code will work for both the cases, even if you don't have any node in the linked list, even if you have some nodes in the linked list. Got this thing, guys? Insert at and insert at beginning. Clear? Is this clear? See, you just need to play with these pointers. Okay, and you just have to think logically. Okay, which one to place, which one to link first, and then which one I would link. That's what you have to check. Okay, am I not audible properly? Am I audible properly? I hope I'm audible properly. Okay, audible, right? Okay, fine. So this is your insert at end and insert at beginning, guys. So I hope you understood the process. And okay, so it's time for quiz. We are late today because this took some more time. So yeah, Kriti, can we have the quiz, first quiz?
Just a minute, so I'll be sharing the screen.
Sure. One insert at beginning is very like easy. So what you have to do, create a new node and you store address of the first node. Address of first node is stored in head. So head value, if you store in next of new, like new of next equal to head. So new would be pointing to the first node. Then you have to change the head, like head should now point to this new node because new node has been added at the beginning. So this should be the new head. So you write head equal to new after that. That's what. Yeah, guys. So link has been displayed and it will be shared on the chat in a moment. So you can quickly get into the quiz and let me know when you are done. Yeah, it would be pinned up. Mon, I hope you are clear with this operation. Just a moment, just a moment. Yeah, Kriti, can we have the link on the chat? Yeah, it's there, guys. Yeah, thanks, Kriti. It's there. Just click on the link and get to the quiz and let me know when you are done. Yeah, we can have this thing for a full screen, Kriti. This link. Yes, Mr. AK, tree is very much important, tree data structure, but sadly we are not able to touch that topic in our essential. We would be doing that in our advanced course because essential there is some time constraint, so we cannot touch everything here. Also, even this linked list and all, we'll be doing more and more operation. Okay, we have more operation that will be done in advance. Even this. Array operation, some more question also, some competitive coding, and some good questions also, which involves this array thing would be done in advanced course. Because of this time constraint, we cannot touch everything right there. So we are basically doing this essential course, which would build your foundation. Okay, then you would be ready with this would make you ready for the advanced course. Without this, it would be not a good thing to get into directly advanced course. That's what this course is about. Okay, so we'll be soon launching the advanced course. So stay tuned. You get all the necessary information about that. Okay. So there would be a huge difference, guys. It's like here we are doing this insert thing, right? Um, so there are also other operation in linked list which would be touching. Many operations are there actually. So due to this time constraint, we are not able to touch all those stuffs. But yes, in advance, you surely will do all those things. Guys, let me know when you're done with the quiz so that we can carry on with our discussion. So you can take one. Yeah, okay, fine. Let all of you complete with the quiz, and I'll continue. Yeah, I think all of them have done with the quiz thing, so I can move on with our discussion, right? Okay. So, yeah, guys. So let's move on to the next thing. Okay, we are done with this linked list thing. Let's see if I can touch some other topic. So first of all, I'll get into this search operation. Okay, so we are done with array and linked list. There are some other topic also, other operation also. I would like you to take an assignment here. That is, so write me this delete logic. Okay, write the logic for this delete operation in linked list. Okay, so I'll just quickly brief you out what exactly you're going to do so that you can easily. Yeah, great, Vamsi. Congrats. So yeah, if this is the linked list, okay, if this is the linked list, this is the head which is pointing here. If I want to delete at beginning, so it's very easy. What you do is you take another temp pointer, okay, then you shift this head. Now head should point to here to the next node because this node we are going to delete. So now this node should be head. So you have to make this node as head, and then what you have to do, you have to free this temp. Okay, this temp has memory allocated dynamically. So these nodes are created dynamical, right? So you have to free it up. So you when you free it up, this node will be deallocated. Now your linked list starts from here, and this is the head node. This is how you do delete from beginning. You would write the logic like this would be an assignment. I'm just saying like how would you go for. Basically, saying this because of this one. I need to tell this. You have to free the node, okay, which you want to delete. And yes, if you want to delete the last node, okay, let's say there's one more node. Let me delete this, clear this stuff. If it is about delete the last node, then what you have to do, so basically you will go with the same thing, temp. Okay, you will come up to here basically. Okay, so when you reach this node, you have to make this thing null so that this link would be cut down, and you need to have another pointer. Let's say this is D, which would point to this node which has to be deleted. Why I'm taking another pointer here? Because I need to free it up so that when I write free D, this thing will be deallocated. So now this node would be sorry, delete from the end. So I hope you can do this. I have explained the way in which you have to proceed. So rest all kind similar. Like you have to take this while loop and all, save this. Okay, just remember this thing, guys. You have to use this free. Okay, to delete something. Okay, yeah, two pointers are required. Basically, this temp, okay, which would point to the node just before the node which we want to delete. And here it is D, which you can take anything. I'm just taking D because I want to delete this node. That is why I've taken D. So D should point to the node which I want to delete so that I can write this free D thing. Why I'm taking this temp? Because I have to make this next of temp as null. I have to at a point stopping at a node which is just before the node which I want to delete. Okay, voice is not clear. Yeah, Kriti, can you just confirm the same? Is my voice not audible properly?
Yes, sir. Sometimes it's like breaking.
Okay, just a moment then. Yeah, guys, just give me a moment. Let me check my internet connection.
Hey guys, I hope I'm audible now properly. Okay, I'll just keep my camera thing off so that my audio should go fine, even if I'm not visible. I think that's some net issue over here. So, am I properly audible now, guys? Yeah, just confirm me the same. No.
Yes, sir, you're properly audible.
Okay, fine. Thanks for the confirmation.
Yes.
Yeah. So, okay, I'm sharing a screen,
Network issue,
the
voice
same
breaking.
whiteboard. Now it's good, right? Okay, thanks. Thanks for the confirmation, guys. Yeah, I have shared a screen, but that is yet to be shown. Yeah, now it's visible. I think that's some network issue over here. Fine, no issue. So you're seeing this, right? So you need to understand this, and you have to go in this way, guys. So to delete at the beginning or delete at the end. So you just take this thing as an assignment. Let's move on to the next thing, that is searching of an element in an array. I think all of you know this searching. So how many kinds of searching are there? What are the various searching technique you know? One is linear search and one is binary search. Okay, right, linear search and binary search. So yeah, Kriti, we can have this entire board thing full screen as a full screen, because anyway I have turned off the camera because of my network issue. Just make
Sure,
this
sir.
thing entire to be shown in the entire screen. Yeah, thanks. Thank you. Yeah, guys. So we have this linear search and binary search, right? So what is this linear search? Basically, if I have an array with certain elements like 10, 20, 30, 40, 50. Okay, I should not take in this way. Uh, okay, I have this array 3, 7, 9, 12, 1, maybe 8. Okay, maybe this is 5. So indices 0, 1, 2, 3, 4, 5, and 6. So this is the array given, and these are the elements, and I want to search something, and we are going for linear search, right? So what linear search is, basically what it how it works, it would work basically like I'll go on to every element and compare them individually. Let's say I want to search for x value would be something. Let's say we are searching for 8. So what we'll do, first we would compare with a of 0. Array name is, let's say, a. I'll first compare with a of 0, then I'll compare with a of 1, then I'll compare with a of 2, then a of 3. So I'll continuously check whether a of 0, is equal to x. No, 3 is not equal to x. Fine. Next. A of 1 is equal to x. No. Okay, next. I'll then compare 9 and 8, not equal. Next. 12, 8, not equal. Next. 1, 8, not equal. Next. 8, 8, yes. So actually I found out that a of 5 is actually equal to x. So I need to print this location. Okay, the element we have found and it is present at index 5. Okay, right? This is what we need to understand here. So pretty easy this thing. So I'll quickly what I'll do is I will quickly code this for you. Okay. So let me share this screen. Just a moment. Where is the thing? Yeah. Okay. Fine. So I'll just create another file. Let me save this thing somewhere. Okay. So linked. Sorry, not linked. This is linear search, right? Linear search dot c. Okay, fine. So let's get the template ready first. So stdio.h, then this is our int main. Okay, then we need to write return 0. Fine. So first of all we have to create this array, right? So int arr, let's say, and I would just put some dummy values, 5, 7, 2, 1, maybe 9, maybe 12, 3. Yeah, let it be this number of elements. So I want to search for some element, let's say int x equal to, you can take input for this x, but yeah, it's visible. Yeah, I guess it's visible, guys. I'll just increase the font size. Okay, so I have created this array having these elements. Then I'm taking this x. Basically, I should be taking input for this x, the element which I want to search for. But for the time being, I'll not take input. I'll just assign some value. Let's say I'm searching for this 9. Okay, so what I need to do, I have to compare with each element of the array, right? So first I need to compare with a of 0, then a of 1, then a of 2, then a of 3, then a of 4. Likewise I have to check. So at any point of time, if I get the element, then I'll stop there and I'll say, okay, we have found out the element. It is present at this location. So for that purpose, so I'll be taking a loop variable I. So I can go with this for loop for I equal to 0, I less than, how many elements are there? 6 elements, right? So yeah, I less than 6 and I plus plus. So here I need to write if x is equal to arr of I, then what we'll do, we can print here a message like element found at index percentile d I, right? I is the index, and what we can do, we can actually break the loop because I don't want to compare anymore. I have already found the element which I'm searching for, so I don't want to continue the loop anymore. So I would just break from the loop. I'll come out of the loop, sorry. Okay, if at all, uh, let's say I'm not finding it, so what can you do? How can you check that, okay, I have scanned all the element of the array, but still then I didn't find the element? So how can you check? So it's very simple. After the loop, if you check this, if I is equal to n, okay, n here would be size, so size here is 6. Okay, size here is 6. So if I is equal to 6, then you can have a statement that actually I compared with all the element, but I didn't find the element there. So element, I can write element not found, right? This is what we need to do. So you guys, one thing you can do, instead of this 6, you can take some size of the array like n and all, and you can just replace this thing. So this would give me the index of the element. So let me execute this. I hope there's no error in here. Okay, I think it's not visible even to you. Okay, so you see this, guys, see this, it is showing me output as element found at index 3. I hope you are able to see the screen. Yes, element found at index 3, right? It is showing us, like I was searching for this 9 and it's showing me. So yeah, basically this thing, guys. So if I right here, if x value, I'll take something which is not there in the array. Let's say I'll take 50 as the value of x, which is not present in the array. So what it will do, it will compare with all the element. It will not find. So eventually this condition would be false and will come out of the loop. So I value would be 6 by then. Okay, and then we'll say, okay, element not found. No, I'm still showing you this output thing. Okay, I had said like I had given x value as 9. So 9 is present at index 3. Okay, if I say I would, instead of 9, if I search for 50, which is not there in the array, so it would compare with all the element of the array, and the loop would come to an end because there is no element, so will not break. So this condition where which we had written after the loop, if I is equal to 6, I have written 6 there because there are total 6 elements. In actual program we will be taking this n. So if I would reach n, that means all the element had been scanned and we did not find the element. So in that case we'll print element not found. Okay, that's what we are doing. So this is all about your uh, in linear search, guys. Okay, so I think Riti, we can have the second quiz on the linear search.
Yes, sure.
Okay, fine. Yeah, guys, so the link is on the screen, and yes, it would also be shared on the chat, so you can directly click on there. Just a moment, it would be shared in the chat. Yeah, guys, so link has been shared in the chat. You can directly click on there, get to the quiz, finish it as soon as possible. Let me know. We would continue our discussion. Let's be a little fast, okay, guys? Hey guys, are you done with this quiz? Let me know, guys, as soon as possible. Okay, so yeah, Kriti, so they are done with the quiz thing, so we can get back to our discussion screen. Okay, so I'll be taking you back to the whiteboard, guys. So that's where I want to discuss something, that is binary search. Linear search is quite easy and we understand this thing. Let's go for this binary search. And I think you already know like something about this binary search. So can anyone tell me like what is the prerequisite for binary search?
Excuse
Prerequisite
me,
for,
sir. Sorry
yeah,
to
yeah,
interrupt you.
yeah,
Uh,
say.
s- there is some technical issue. Could you please reshare your screen?
Okay, fine. Is it fine
Thank you
now?
so much. Yeah, yeah, it's fine now.
Okay,
Thank you so
okay, great. So you can just put it on the full screen mode. That would be great. Yeah, okay, guys. So, yeah, binary search. So, what is the prerequisite, guys? Yes, sorted array. So, the array needs to be sorted already. Binary search can be applied only on a sorted array. If the array is not sorted, then binary search cannot be applied. So, this is one prerequisite, guys, for binary search. And I think you might have already seen the question in the quiz in linear search, the time complexity about linear search. So basically, it would be big of n, right? Because we are comparing with each element of the array. In worst case, we would be comparing with all the element of the array. Best case would be if we find the element in the first place itself. That is the best case. Worst case is if the element is not present in the array at all. So we would end up comparing with all the element of the array. That is big O of n, worst case time complexity. Binary search, let's see like how it works. So one thing is, yeah, I mentioned like array should be sorted already in order to apply binary search. So maybe 2, 3, 5, uh, 8, maybe 10 and 13. Yeah, 0, 1, 2, 3, 4 and 5. So how does this the binary search work? So binary search, what it does is it divides the array into two parts, guys. Okay, and in next like in the next time, in the next iteration, it would go to any of this part, either left side or right side. Okay, so let's see how it works. So we have something called this beginning, which would be 0, and we have this end, which would be n minus 1. Basically, the index of the last element of the array. Okay, so we would go with this while beginning is less than, let me write it down and I will be explaining this. While beginning is less than equal to end, why equal to end? See, till beginning would be less than end, it would run. Also, why it is equal? Because at a time, there would be some point of time like you would end up or there would be only one element left out. So we just need to take care of that situation also. That is why I have written beginning is less than equal to end. Okay, so while beginning is less than equal to end, Biz Kishore, no, it is not like binary search tree. And why it is not, actually we would discuss. Like the what is that? We'll discuss that in tree when we discuss that in advanced course. This tree thing, you'll get to know how it is different from the binary search tree operation. Okay, so see here, while beginning is less than equal to end, so why equal I have taken? Because there might be at some point of time, there might be only one element left out, so we need to take care of that. So while beginning is less than equal to end, I will every time I'll calculate the midpoint, and midpoint is nothing but beginning plus end by 2. Okay, beginning plus end by 2. There is some other way through which you can actually find it out, like beginning plus end minus beginning by 2. Also this way you can find it out. This actually is preferred, guys. This way of finding the mid is preferred. Why it is preferred? That's your task. Okay, just find it out. Just have a homework. Why finding out mid in this way is preferred over this way. Okay, fine. So we have calculated the mid. So here if you check what is mid now, so beginning is 0, mid is okay, end is 5, and mid is 0 plus 5 by 2, that is 2. So basically mid is here. So what we would do is we'll compare with mid, guys. So if x is equal to a of mid, if x is equal to a of mid, basically uh, if middle element is the element which we are searching for, then we can directly return this index mid, because we know, okay, the element which we are searching for is present at this mid location, that is 2, because mid value is now 2. Okay, it may not be. Let's say we are searching for X value we have taken, let's say for example 10. For example, let's take 10. So obviously mid is 5 and 5 is not equal to 10. So what we would do now is we now have to check. Okay, so we are searching for 10. So where it would lie, if it is present at all. So whether it would present on the left of left array or on the right array. See, at this mid, this array is getting splitted. So whether we'll go to left side or we will go to right side. Okay. So see, so how we would check? We'll check if x is less than a of mid, then we need to go to left side because already the array is sorted. So if the element which we are searching for, that is x, if it is less than the middle element, then obviously it would lie in the left side. So if it is lying in the left side, so the next time I don't want to search in the entire array, I'll just search in the left side. So what we can do is we can just make this end as mid minus 1 so that I would search only in this part. Okay, so okay, I can write here else if actually. If x equal to a of mid, return mid. Else if x is less than a of mid, go to left side. Otherwise, if both the conditions are false, then obviously it would be on the right side. Mid is not like x is not equal to a of mid, x is not less than a of mid, obviously it is greater than a of mid, so it must be present. If it is present, then it must be present in the right side. So there what you can do is you can just make this beginning as mid plus 1. Okay, that means next time I will be searching only in this part. So beginning is here, end is still here. Okay, right? So this is what we are doing. So as we have written this in the while loop, again the loop will run, again this mid would be calculated. So what is the beginning value now, guys? Beginning is 3, end is still 5. So new mid would be 5 plus 3 by 2, 8 by 2, that is 4. So now mid is here. Now this condition will be satisfied. X is equal to a of mid. X is 10, a of mid is also 10. So it would return this index mid. So you have found out the value. Let's say you are searching for something else. Let's say I am searching for 15, which is not present in the array. So even now this condition would be false. X is equal to a of mid. Middle element is not 15. So and yes, 15 is greater than the middle element. So what would happen? So I have to go to right side. That means beginning would be updated to mid plus 1, that is 5. You see here. Now beginning is also here, right? Beginning is also here. So we are left out with one element. Beginning is 5, end is also 5. So that one element can also be the element we are searching for. That's why I have taken here equal to, guys, so that our loop would run one more time. We would check whether this element is the element we are searching for. So this is how this binary search works, guys. Okay, I hope you are getting this. You follow this thing. Are you following, guys? Binary search, you followed, right? You understood. One thing is prerequisite side, that is nothing but your array should be sorted. Second is this will go with this beginning, end, and mid. Okay, we'll continuously find this middle of the array, and in the next iteration we would go either to the left part or the right part if we didn't find the element. Okay, as the array is already sorted, we are just comparing with the middle element. If x is less than middle element, that means the element which we are searching for would be on the left side. If it is present, it may not be present, that's a different case, but it would be on the left side. If x is greater than middle element, then it would be on the right side. So that's what we are doing. Got this, guys? So if x is equal to a of mid, return mid. Else if x is less than a of mid, end equal to mid minus 1. Else big equal to mid plus 1 finally. So that's what we are doing. Okay. So I hope it's clear, guys. Binary search. So Kriti, are you there now? Okay, fine. So
Yes, sir.
Yeah, so can we have the quiz on this binary search?
Sure, sir.
Okay, fine. Thanks a lot. I just put it on the full screen. Yeah, guys, so this is your like link for the next quiz. Get into this link, and as soon as possible you complete the quiz. And I have one more thing to discuss. Yeah, the quiz link has also been shared in the chat, so just directly click on that, get to the quiz, complete it as soon as possible, and let me know quickly. Yeah, do let me know, guys, when we're done with the quiz. Done, guys? Everyone? Is it done for everyone? Okay, fine. Uh, yeah, Kriti, we can be back to our discussion screen. Okay, great. So, yeah, guys, I hope every one of you are done with this quiz thing. So, let's get back to our discussion where I'll be discussing one sorting technique that is the most like the very first sorting technique, that is your bubble sort. Okay, let's have a discussion on it. So, bubble sort, where is that bubble sort? Do find one thing, guys. So why the name is bubble sort? Okay, just have some research and get to know that why the name is bubble, why they named this sorting technique as bubble. Okay, so bubble sort, let's see this. So I have an array basically, so 2 3 maybe 7 3 5 1 8. Oh, not 8, let me take some other value, maybe 4. Yeah, this is what we have in the array: 0 1 2 3 4 and 5. Okay, so what bubble sort do? So obviously this is a sorting technique, so it will sort the array, and we are looking for this sorting the array or arranging the elements in ascending order. So when I say sort, basically it would mean this ascending order. Okay, sorting. When I say reverse sort, it would mean descending order. And here's one more question, guys, I forgot to mention, like one more assignment thing, that is we discussed this linear search, binary search. Also you need to write the logic and or code for ternary search. Okay, I'll just give you a quick idea about it. In binary search, we divided the array into two parts. In ternary search, we will be dividing the array into three parts. Okay, that's what. So you have to find mid one and mid two, right? So you can find out mid one and mid two. That's what. So you'll find beginning plus end minus beginning by 3. This is mid one. Okay, then mid 2 would be like end minus beginning by 3, kind of this. Okay, just have a research on this and do that. Okay, ternary search. So array would be divided into three parts. Yeah, so I'm just erasing this thing. Okay, yeah, so let's focus on this bubble sort. We have an array here and we want to sort it, and we are now applying this bubble sort algorithm. Okay, so in bubble sort, in the trivial algorithm, what happens? So we will compare adjacent elements, like this 2 and 7 will be compared, whether 2 is less than 7. So, sorry, we should check whether 2 is greater than 7. No, right? So nothing to be done. Now we'll compare 7 and 3. So 2 is still there. 7 and 3. Whether 7 is greater than 3? Yes, 7 is greater than 3. So they need to swap. So 3 would come here, 7 would come here. Then 7 and 5 would be compared. Is 7 greater than 5? Yes, 7 is greater than 5. So we need to swap it. So 5 would come here, 7 would come here. Then 7 and 1 would be compared. Is 7 greater than 1? Yes, it is greater than 1. So it needs to have a swap. So 1 would come here, 7 would come here. Then 7 and 4 would be compared. Finally, they would also be swapped. Okay. So this would be the array content after one pass, basically. So in one iteration, in one pass, the largest element would be placed on the rightmost side. Okay, the largest element would be placed on the rightmost side. 7 here is the largest element, so that is being placed on the rightmost side. And again, if you then we will continue the same process. So 2 and 3 would be checked. 2 is less than 3, nothing to be done. Okay, same thing, fine, 2 is still there. Then 3 and 5, okay, 3 is less than 5, nothing to be done. Then 5 and 1 would be compared. 5 is greater than 1, so it would needs to be swapped. So 1 would come here, 5 would come here, 5 and 4 would be compared. So so then it to be swapped. So 1, 4 and 5. Now 5 and 7, if you're comparing, obviously 7 was the largest element and we have already put it on the rightmost side. So do we need to compare this 5 with 7? No, right? We don't have to. We don't need to compare it with 7. So what we can do, we can write our code in a way so that it will not compare with the already arranged uh, element. Okay, got it? So let's see this bubble sort thing. So this is the bubble sort logic. It will take this array. Okay, maybe this int a, and also maybe this size of the array. Fine. So what we will do here is, I'll run this loop for I equal to 0, I less than n, I plus plus. For j equal to 0, j less than n minus 1. I'll tell you why I've taken this j less than n minus 1. Inside the inner loop, what I'm checking is, I'm checking if a of j is greater than a of j plus 1, like if the current element is greater than the next element, then I need to swap it. And I think you already know how to swap. So swap a of j and a of j plus 1, right? Okay, this is what we need to do. How to swap, guys? Just take a temporary variable temp equal to a of j, then you write a of j equal to a of j plus 1, then you write at a of j plus 1, you would be storing this temp. So this exact thing we need to replace here. So if a of j is greater than a of j plus 1, just a moment guys, I see. Okay, fine. Yeah, so is it now visible to you all, this whiteboard? Just a moment, I'm facing some difficulty out here. Is it visible guys, the screen, the whiteboard I have shared? Let me know in the comment section. No? Now is it visible? Okay, not visible yet. Let me check out. Yes, right. Okay, fine. So yeah, let's get back to our discussion. So we are checking if current element is greater than the next of element. If a of j, if a of j is greater than a of j plus 1. J is the current element, and we are checking whether a of j plus 1 is greater. Sorry, if a of j is greater than a of j plus 1, current element, if it is greater than next element, then we need to swap, because we need to take this largest element towards right side. Okay, so now coming to this point, why I have mentioned it j less than n minus 1. The reason behind this is that I'm comparing a of j with a of j plus 1. So if j would go to n minus 1, then what is a of j plus 1? J plus 1 would be n. There is nothing in a of n. You are going out of the bound of the array. Are you getting my point? So a of, that's why I have taken this j less than n minus 1, so that maximum j would go to n minus 2. So I'll be at the last step, I'll be comparing a of n minus 2 and a of n minus 1, because n minus 1 is the index of the last uh, value. Okay, last element. That's what I need to compare at the end. So this is how we go for it, guys. So we'll compare if a of j is greater than a of j plus 1, then we swap it. If not, nothing to do. Okay, right? So this thing would continue basically, and after the completion of this entire logic, your array would have been sorted. Like first, the largest element would be put on the rightmost side, then the next largest element would be put on the side. Okay, so likewise, let me clear out this stuff. Okay, guys, one more thing here I need to explain. As I said, do we need to compare with the last element? No, right? Not only the last element. Every time you are sorting, like every time you are running the loop, the after first iteration, the last element would be sorted. You don't have to touch it. You don't have to compare with it. After second iteration, next highest element would be sorted, would be placed at its correct place. So you don't have to touch these two things. Similarly, in the next iteration, so after first iteration, one element would be sorted. After second iteration, two element would be sorted. After third iteration, three element would be sorted. So we don't actually have to compare with them, right? Okay. So what we can do is we can actually uh, change a bit. Let me write this once again in a clear manner. So we don't have to compare with those right elements. Okay. So if this is your bubble sort, it takes some array and size. So this is your loop for I equal to 0, I less than n, I plus plus. Then your for j equal to 0, j less than n minus 1 is what we were writing. Now I will write n minus I. j plus plus, and we would do if a of j is greater than a of j plus 1, then we would basically swap this a of j and a of j plus 1. This is what we have discussed. Okay, right? And then after the completion of this loop, we would say, yeah, so the entire thing would be sorted. So if you see here, if you notice this thing, j less than n minus 1 minus I, first when I would be 0, j would go till n minus, like j would go till less than n minus 1, that means n minus 2, up to n minus 2. Next time I would be 1, so it would go till n minus 1 minus 1, that is it would go till like less than, this is less than n minus 2, now it is less than, yeah, tell me guys, are you following whatever I'm saying here? First time when I is 0, it would go till like less than n minus 1. Next time I would be 1, so it would be less than n minus 2. Next time I would be 2, so it would be n minus 3, less than n minus 3. So basically, I'm not comparing with the right elements in every iteration. In the every next iteration, I'm not comparing with those elements. Okay, so after first, see, in the first iteration I'll be comparing with all the elements. In the next iteration, when I value would be 1, so j value would go maximum up to n minus 2, right, n minus 2. So it would just compare, so I will be comparing n minus 2 and n minus 1, kind of this. Okay, I should not say n minus 2 and n minus 1 actually, because this is done at in the first iteration. In the next iteration, it would be like n minus 3 and n minus 2. Comparison would be done between a of n minus 3 and a of n minus 2. Okay, so this is what we are doing here, guys. Just let me know if you understood this point, whatever I'm trying to say. Okay, so I actually erased the array, that's why I'm facing some issue to clearly mention this thing. I should not erase that array. Next iteration we don't want to compare with 7, then we don't want to compare with 5 and 7, then we don't want to compare with 4, 5 and 7. So this is basically you can say, yes, this is a better version of bubble sort than the previous one. Okay, this is a better version because we are reducing the number of times, the number of comparison actually. By writing this minus I in every step, we are reducing some set of comparison. Okay, okay, anyway, fine. So this is bubble sort, but see guys, can we further improve it? The question is there, can we further improve it? So in data structure, when you are writing an algorithm, so we have to think about, like, can we further improve this algorithm? Answer, we need to think yes or no. And here the answer is yes, we can still improve it. We can have a more efficient logic for this bubble sort. Okay, yeah, Raghavendra, you didn't understand this j less than n minus 1 minus I. See, okay, when first time I would be 0, so let's say I have certain elements here, 2, 3, maybe 2, 5, 3, 7, and 1. Okay, so first time everything would be compared. Okay, in first iteration, 2, 5, 3, 7, so everything would be compared. So 2 would come here, 3 would come here, 5 would come, okay, yeah, 5 would come here, 1 would come here, and then 7 would come here, right, after first iteration. Now I don't want to compare with 7, so I will just compare 2, 3, then 3, 5, then 5 and 1. So 1 would become here, 5 would come here. 5 and 7 I don't need to compare. 5 and 7 I don't need to compare. That's how this thing will work now, because I have written minus I, so j will not go up to this point so that it would compare 5 and 7. J would stop here, so the last comparison would be done between this 5 and 1. Okay, clear, Raghavendra? Got this point? Understood this, Raghavendra? Zero, 1, 2, 3, 4. Okay, first time J would go till 4. Okay, next time J would go till 3. Kind of that. Okay, sorry, first time J would go till 3, but next time J would go until 2, till 2. So 2, 3, A of 2, A of 3 would be compared, nothing more than that. Fine then. So yeah, I was saying about we can further improve this, further improvise this. And how to improvise this, guys? See, let's say you have an array, this one, 2, 3, 5, 9, 7. This is your array. Okay. So after the first iteration, what array you will get, what content you will get, what would be your array after first iteration? This would be 2, 3, 5, 7, 9, right? This would be your array. You can see the array is already sorted, but as per the algorithm, the loop would still run. The loop would compare 2, 3, then 3, 5, then 5, 7. It will compare. Nothing would be done. Fine. In the next iteration, again it would be compared, like only 2, 3 and 3, 5 would be compared. In the next iteration, 2, 3 would be compared. So the as per the loop, it will not stop. We can see that, okay, yes, it is already sorted, but how that algorithm is going to know it is already sorted and it will not compare anymore? You have written the code, you have written this nested loop, so that would run, right? So that would check, that will run for all the possible iteration. It may not swap, but it will check. So there is a way here where we can stop this unnecessary comparison. We can stop the loop right away here. Okay, we can stop the loop right away here when we know that it is already sorted. So how can we do that here? See this. When there would be swapping, guys, if the number would not be, if the elements are not sorted, then this swapping occurs, right? Only then this swapping occurs. When there is no when there is elements which are not sorted, if you find some elements which are not sorted, then this swapping occurs. If elements are already sorted, then no swapping would occur, right? So what we can do is we can take some variable kind of thing, maybe swapped. No, just take some like 2 to 3 more minutes. So you can take a variable, flag variable, swapped, whose initial value would be 0, let's say. In every iteration, I'll make this swapped as 0. If we are swapping anything, then I'll make this swapped as 1. Okay, I'll make this swapped as 1. So if you see this value of swapped is 1, that means some swapping has been done. If swapping has been done, the array is not sorted yet. Okay, so one thing you keep in mind, if value of swapped would be 1, that means some swapping has been done, and if swapping has been done, that means the array is not sorted yet. Okay, right? So this inner loop would be over. Now after the completion of inner loop, we will check what is the swap value. If swap value is still 0, that means there was no swapping needed. That means the array is already sorted. So in that case, we can actually break the loop. We don't want any more comparison. Array is already sorted, and that's the reason why no swapping was carried out. So, and swap value is still 0. That's why. Did you understand this point, guys? What I have done? Unnecessary comparison I stopped. See, first time in the first iteration 2, 3 would be compared, 3, 5 would be compared, 5, 9 would be compared, 9, 7 would be compared. So there is swapping. So there would be a swapping. So swap value would be 1. Fine. You would check if swap equal to 0. Okay, false. Because swapped, there was swapping and swap value is 1. In the next iteration, 2, 3 would be compared, no swapping would be done. 3, 5 would be compared, no swapping would be done. 5, 7 would be compared, no swapping would be done. So what would be the value of swapped? Swapped would still be 0, because every time we are initializing, in every iteration we are making swapped as 0. So swapped value would still be 0. Now after this loop, after the completion of this inner loop, we are checking if swapped equal to 0, break. So we are coming out of the loop. So we are stopping the algorithm here. We are not making unnecessary comparison. If no swapping is carried out, that means the elements are already sorted. We don't have to move anymore. Like we don't have to carry this algorithm anymore. So this is an improvised version of bubble sort, guys. So why I say this is, let's say you are sitting for an interview, and so before you, your friend or somebody might have gone there for interview. So interviewer has asked, write the logic for bubble sort, and your friend has written the previous code, and you have written this code. So you definitely now see like where this is going, right? So obviously you would be the preference, right? Because you understand this thing pretty well, like how exactly this thing, how can I write the code more efficiently? Yeah, this is a efficient version of the bubble sort as compared to your what your friend has written. So I'll be going with this. Obviously interviewer will go with you. So that's where it makes difference, guys. That's where this competitive coding and this understanding this whole concept of data structure comes into picture. It's not only right like doing things the trivial thing, but it's about like how we can do it in a better way. Okay, data structure is all about doing it in a better way. How efficient our code is. Okay, obviously it would be like storing data, how we would be storing data and all. Also in an efficient way we should do operations. Okay, so that's what we discussed in the first session. Time complexity, best algorithm, less time complexity it should take, right? Okay guys, so I hope you understood this point, and all the things what we discussed. I think it's clear. So I think we can close this session off. Or
So
guys, you can go with the quiz, or you would like to go with the quiz, guys, or bubble sort. Let's go with the quiz, and then we can end the session.
all
Okay,
right, sir.
right?
All right.
Yeah, Kriti,
Yeah.
you can actually share the quiz of bubble shot. Let them do that, and we then close this session.
All right. So I have shared the link in the chat, guys, and I'll also be sharing the screen. Yeah.
Yeah, guys. So link has been shared. You can directly go to that quiz and answer the things. Let us know when you are done, so then we can close up the session. Okay, we won't like to take your any more time. Yeah, have we not shared attendance link, Kriti?
Yes, sir, it's there in the description box, and also
Okay.
you can refresh it and get it, sir.
So guys, yeah, I guess you heard that. Just go to the description section and you would find the attendance link there. Whoever hasn't put your attendance, kindly put your attendance in the description. Like you'll find the link there in the description box. Everyone's done with the quiz. Okay. Okay, fine then, guys. I hope every one of you are done with the quiz. So, and I also hope that you understood every single point which we discussed in this. Okay, please let me know in the next session if you have any doubt regarding this session. We would first cover that thing. Okay, so yeah, guys, thanks for your time. Thank you for bearing for me for this long. We'll meet in the next session. Take care and bye.
Thank you, sir.
Yeah, thank you, Preeti.
Thank you, sir. Guys, do not forget to fill your attendance, and also it's there. I have sent the links in the chat and also pinned it. Yeah, and you can find the attendance in also in the description. So please fill your attendance form, and we'll meet tomorrow at the same time at 6 o'clock. Thank you.